Okay, so our final talk in the morning is from Dr. Randy Jackson. He's a senior research associate in the Department of Natural Resources at Cornell and also the associate director at the Cornell Biological Field Station on Oneida Lake. Randy received his bachelor's from Montana State, master's from Texas A&M, and PhD from North Carolina State. And he worked 13 years in North Carolina on reservoir fisheries, and now his focus is on Oneida Lake fisheries. But today, he's going to talk to us about climate as a driver of the homogenization of newer extreme fish assemblages. Randy?
Well, you've already noticed that resilience is not part of the title of this talk, and I'll confess up front there's not a single cup or ball anywhere in here. But I think when it's all said and done, that maybe this relates to the overall topic themes. In New York State, we're quite lucky if we want to answer questions about long-term changes in our faunal diversity that Emmeline Moore was hired by the New York Department of Conservation back in 19 whatever it was. Emmeline did a biological survey, part of biological survey on Lake George back in the day, and was inspired about the value and importance of having thorough inventories of our aquatic resources in New York State, and wound up being the lead and director of the watershed surveys we've all heard so much about that occurred between 1926 and 1939, covered all the major watersheds, and produced very good books, but more importantly, very good inventories of fish species distributions around the state. Included ichthyologists such as Reeve Bailey and Ted Rainey. John Greeley took the lead on most of the write-ups. And it was an incredible effort. Over 4,000 sites were sampled, a little better than 140 different species of fish, and very detailed reports produced on each watershed and what was found. We're also lucky that Doug Carlson came along at some point and got it in his head that it might be nice to see if we could reproduce that or produce a comparable data set on the same scale. So Doug sampled a little over 3,000 sites in the early 2000s, and Bob Daniels should also get some credit for working with Doug on the fish IDs and that kind of thing. And that's where I came in. Doug approached me what feels like 5 or 6 years ago now, maybe 10 or so in his memory, about what kind of analytical pressure could be put on these data to take full advantage of it. My initial answer, because it was true, is I had no idea, and he asked if I would work on it anyway, so I did, and started playing around with Doug's data in comparison to the historical data to see if we could detect changes and learn something about what's going on in New York State. So these are the data that is set up, like I said, over 4,000 site sample in the historic survey, over 3,000 by Doug. They're not true replicates, but all the watersheds are represented. Sample size within any given watershed varies roughly in proportion to the size of the watershed, but also things like how interesting Doug found the watershed to be. The Allegheny has particularly rich fauna, so Doug spent a lot of energy there. But again, mostly comparable from watershed to watershed, so very solid and strong data set to look at fish species assemblages across the watersheds and how they may have changed from the 1930s to now. Quite diverse fish fauna. I'm sure you can all read that table, but we had over 161 species found over the two surveys. There were 10 or so in the first survey that did not come up in the second, and 10 or so in the second that were not in the first. Over 27 families, so we have an incredibly rich fish fauna and quite a bit of diversity to look at these things about what have changes through time done to a wide variety of species with different life histories. Because of the nature of the historical data, the data had to be pared down to presence absence. We couldn't say, well, we caught this many darters at this site, this many of this species at that site. We pretty much had to say, was a species detected at a specific site? And that gives us presence absence data. And as my reading did after Doug asked me to analyze, contingency tables were a pretty good way to go. It never helps to hit the wrong button to go about doing these analyses, and therefore we did that to look for whether or not there were significant differences in the proportion of sites that a species was detected at within and across watersheds. There's now an appendix of 130 pages of stats output and figures. And rather than give a talk, you can just appreciate for yourself what we've seen here. This is from the Allegheny River, I think. Incredibly powerful data set because of the 4,000, 3,000 site thing. So we're correcting the significance value of Bonferroni correction based on the number of species within each watershed. I'm not sure that's necessary or required, but what happens with the data set with this much sample size is everything winds up being significant. You get balled up with that, well, is this an ecological significant change or quantitatively significant change? The Bonferroni way was kind of a way to dampen it down and spread out our horizons a little bit, and that's kind of the nuance. And these are the kind of examples we get. These are the proportion of sites, again, within each watershed that a species was seen at historically and in modern times. And these are the kind of patterns that are not that different from one watershed to the next. Antarctics, by and large, are big winners in almost every case in every watershed. The proportion of sites that our Antarctic species were detected at went up. Relative to historic sites, the salmonids did not fare so well. Brook trout in particular seem to be having a tough time. Minnows, some did well, some did not. But these are the core data that I've been looking at. Now, it occurred to me that the data set's nice enough, and Doug worked hard enough, that it really deserved more than a bunch of graphs with error bars on it with no interpretation. And from what I knew about fish faunal surveys and analyses, which was next to nothing, there'd been a fair amount of yapping about homogenization of fish faunas across large landscapes like the United States. I'd been teaching about this in class at Cornell, but that didn't require that I know anything about it. But once I decided that I was going to try to do some analyses, and I thought maybe I better learn some. And that wasn't the right place to start. It turns out that Frank Grayhill, who I met a few years back, had published a paper in Science back in 2000, where he compared the faunal assemblages of the United States in pre-settlement times. And I asked Frank where he got those data, and I never understood his answer. Apparently he had a fairly exhaustive species list for every state in the country before anybody was here. And then he had equally exhaustive species list of what was in the states after people did get here. And what he was looking at was whether or not the states were becoming more similar, which would be homogenization, or less similar, which would become differentiation. And what he found was, on average, the fish fauna in the different states were 7.3% more similar now than they used to be. And Frank came at this from a stocking perspective, and he thought most of the change was because of intentional widespread stocking of cosmopolitan species like bass, that when agencies discovered early on that Californians were likely to suffer developmental abnormalities because they didn't have largemouth bass, we hauled some bass over there, and things like that. So extirpation can also lead to this. You lose these unique species in given states, then that increases similarity. But for the most part, he thought the driver was stocking, leading to states sharing more species now than they used to historically. And that's what homogenization is all about. Doug's data are better than that. They're not purely presence or absence, at least within the state. We've got proportion of sites within each given watershed that species occur at, so we don't have to be constrained by that this species expand the number of watersheds, or bass by and large going from being at 10% of all the sites in a watershed to 20 or 30%, because that also would lead to homogenization across the state. I was not nearly smart enough to analyze data at that level, but fortuitously, we had a primer workshop, multivariate statistical routine, extremely powerful software at our station back in just past November. I signed up for it mostly because I think it was expected that I should be interested in learning new stuff, even at this stage of my career. And not only did I sign up and spend DC's money taking it, I actually went to all 5 days of the workshop. And I have to say, I think when I first got here, I did some cormorant analyses of multivariates, and I got up here and talked some smack about multivariate statistics as being just some way you can play with stuff until you get a picture that agrees with your preconceived notions and go for it. But it turns out Primer has significance tests and ways to keep you honest, which really appeals to me. And so I sat there and said during the workshop, boy, this homogenization question really does seem to go into this well. So the input data are going to be the proportion of sites in each watershed that each species was detected at historically and in modern times. Transformed within an inch of their life, because the endemics are important, you want to make sure that they carry weight in the analyses. Calculate Bray-Curtis similarity indices for all of them. There's also an antisim function in Primer that mimics an ANOVA to see if there's a difference. And I can tell you now there was a difference, but I can't tell you the p-value because apparently my license to the software was only for the shop and it ran out. So when I tried to look that up yesterday to give you the p-value, I was unable to get it. This is going to be the extent of the analysis until I cough up some more money. And then there's the visualization technique, the non-metric multidimensional scaling, which is really cool. I'm sure we'll all be very excited about that when we get to it. So here we are at the similarity comparisons, and this compares each watershed to all other watersheds in the historical survey in the 30s and the modern survey in the 2000s. And in every case, the watershed is more similar to its other watersheds in the state now than it was historically by a factor of about 4.1 something. It's comparing apples and oranges, but note that Ray Hill compared similarity from before there were any people to 2000 and got an increase of 7.3%. We're talking about 70 or 80 years and we get an increase of similarity of about 4%. That's pretty remarkable. But what we can see is that in all cases, the watersheds are becoming more similar to one another. We can also look at how the watershed compares to the rest of the state, the statewide fauna. And that's not quite so clear-cut. In almost all cases, there's an increase. So that each watershed is more similar to the statewide picture than it used to be, with a few exceptions there. And about a 3% increase there. And this is the non-metric, whatever it is. And I've never been a big fan of these kind of pictures either because there's nothing on the axes so you can say, well, this is going up or this is going down. But what I found was really cool is all this is trying to do is to place the watersheds in a space so that their relative distance from one another is proportional to their similarity. So there's no geographic input. And it winds up, it gives you a map. There's Long Island, there's Genesee and Lake Erie, and whatever else, Allegheny. Other than a little bit of confusion about Lake Champlain, this essentially makes a map of the state, which I think is very cool. And then you have the old survey and the locations, and then the new survey with their locations. And in those cases, there's a drift towards the central point, which is the statewide. So eventually this says the same thing that those statistics say, that the watersheds have changed in a significant way, and they're moving in a direction that increases the similarity with each other, which I think is a pretty clear statement that there's homogenization going on in New York State. The next question would be, well, how come? And for this one, I had to take a little different approach. The results that I've presented up to this point I had for some time, and for reasons I'll explain, I started to think climate might be important there. But I wanted to be very careful how I approached it. And some caveats in the overall data set is that Doug had access to electrofishing technology, the other guys didn't, so we have some different catchabilities going on in catch rates. So I think that's bucketed somewhat by the fact that we're talking about presence, absence data, but I threw out the darters and lampreys, groups of fishes that are uniquely susceptible to electrofishing so that they would not be noise signals. Also threw out new invasives because we want to get excited about catching fish that didn't exist in the state before. And what I'm looking at here is not these proportion changes, but simply the net change in the number of watersheds a species occurs in. So now it doesn't matter. The technology differences, again, are buffered somewhat by all that the historic survey had to do is find species one time, one site, and one watershed. And I'm looking at larger scale changes as a species now in more watersheds than it used to be. And we have winners and losers. So this is kind of the distribution of net change in number of watersheds between the two surveys. We have 20 some odd species that actually increased their range by 3 or more watersheds, and 11 species that exhibited reductions in the number of watersheds they were in by 3 or more watersheds. And these are the ones I'm going to focus on for now. Of the losers, 5 cyprinids, 1 sucker, catfish, a couple salmonids, and a percid. Oddly enough, the percid is walleye, which are widely stocked. They actually declined by 3 or 4 watersheds. And what happens looks something like this. You've got the long-nosed sucker, which is fairly ubiquitous, or not ubiquitous, but widespread. Disappeared from actually some of these northern watersheds, which is a little surprising. The climate's going to be there, so this could already undermine my arguments. Disappeared from the western part of the state. Then you've got a shiner that was also very widespread early on. disappears from some of the southern tier watersheds and down here. So these kind of patterns we're looking at, this is where they were in the old days, this is where they were now, looking at where they disappeared from to see if there's any kind of signal there in terms of whether it's always the southern or eastern watersheds. Another example, it's hard for me to read from up there, fine scale dace, which has disappeared from all these habitats here. It's now constrained pretty much to the North Country. And our big loser, for those of you who want to keep track, is lake chub. It has lost the most watersheds. It's down by 7. And again, looks to be mostly in those watersheds where we might expect there to be some cooler water. A lot more winners and losers, and a lot more diverse group of fish represented. We have your gars and your bowfin, one herring, the gizzard shad, 7 cyprinids, suckers, catfish, the sausage, keelyfish, temperate bass, citarchids, and sticklebacks, silver sides. And the big winners here, the black crappie, which went from being in a handful, not a handful, but fairly disparate distribution across the state to every single watershed in the state. The yellow bullhead, which was fairly constrained to the southern part of the state, now expanding up into the North Country. The gizzard shad, which was only in Lake Ontario and Long Island, now pretty much all over the state, still not a little bit up in that St. Lawrence area, but they've expanded pretty dramatically. And the really big winner here is the green sunfish, which went from just a couple watersheds in the southern tier historically to all over the state now. So I've probably integrated myself in the 15 years I've been here so well into what I guess we now know are New York values that you don't realize that I came from the South. And what kept popping up at me while I analyzed all these data is that the species that were doing well were species that I had spent the first 17 years of my career working with. And the ones that were disappearing are fish I'd never heard of before. And there seemed to be something going on there. So the climate change question started popping in my mind, and I was trying to answer, how can I answer this? The data are such that I think anyone with a little free time can figure out a way to analyze it, to say, damn right climate change is causing all of this. And I didn't want to do that. I wanted to ask it in an honest way and ask it one time and see whether or not the answer was compelling or not. And it's reasonable to expect climate change might be causing something. We've got all this historical patterns, and you might be noticing the running commentary. This stuff may or may not be real, but New England in particular is a hot spot in those areas in the state where we see species dropping out and coming in. The North Country and the southeast corner are particularly active in terms of weather change, so that's kind of tempting to think about. And we've got gobs and gobs of modeling. Now this literature that I just recently got into, there's a lot of it, but the modeling exercises outweigh empirical papers on something like 1,000 to 1 scale. There's not that much data looking at this, but an awful lot of people saying, well, yeah, it's going to happen. So you get a study in France that says this warm water species is going to explode, this cold water species is going to disappear. You get people saying warm water species are moving north, even though I couldn't find the data that supported that, but that's what we would expect. And more projections about what's going to happen in New York again. In some of the areas where we see particularly active periods, predictions that cold water species will give way to warm water species. So I said, well, let's see what's going on here. And one way to look at this to see if my gut instincts about southern species and northern species is true is to look at the ranges of the species, the native ranges. And you can see these are the species that decline, the losers. And in almost every case, they're species that are near the southern end of their range here. Unfortunately, these maps don't include Canada or Mexico, so you can't see these guys extend further north. But these are not southern species. These are the species you predict would be in trouble if climate changes or water temperatures warm, because they're already about as far south as they can tolerate. Conversely, for those species that increased, they're all species whose ranges go right down here. The green sunfish and gizzard shad run way down into Mexico, but this, again, is consistent with the modeling theory. Northern species are going to contract their range. Southern species are going to expand their range in places like New York State. The obvious way to go about this, those few empirical studies that exist, actually use the thermal tolerances and preferences of the species they're examining. So the studies focus on those species that are economically or recreationally important, like the trout, where we have detailed energetic data to say this is a temperature that starts to make them uncomfortable, this is one that pisses them off, and this is one that kills them. And that's how you go about looking at this, except we've got 140-something species, 27 families, and a bunch of fish that don't have these kind of studies support them, like quillback and horny-head chub. And you hate to throw away all these species and the diversity that you can answer this question with just because there's only detailed temperature tolerance data for a handful. So what occurred to me is we could use the extent of the range to analyze this. Now, I did my due diligence when I first came to this idea and spent 5 minutes in Wikipedia doing a literature search. And I couldn't find any evidence that people have done this before. If you know of someone who's used range limits as a way to estimate what fish or any other organism do, I wish you'd tell me, because right now I'm inclined to think this might be novel. I'd rather learn it from a friend here than find out from some snotty editor at a journal that it would help if I read more. Essentially, I use fish base to find the southern extent of every species range that occurs in New York State. Ground truth that the Atlas of North American Freshwater Fishes. There were some cases where I didn't agree, but for the most part they did. And I assume that the southern extent would be a measure of their tolerance for warmer water temperatures. And if your range only goes down to Pennsylvania, that would suggest that hot water is not going to be very conducive to your well-being. And if your range goes down to Mexico, that hot water is fine. And this is what we get. If you plot those species that increased or decreased their range by 3 or more watersheds, 40% of variability in net change in watersheds is explained by the southern extent of the species range. So here's your green sunfish, gizzard shad, yellow bullhead, here's your lake chub, fine scale dace, and those guys. I find this remarkable. We've got 80 years of increasing populations and everything else we've done, stocking fish, channelizing streams, all the changes in the state, and for what appears to be a response to climate, or a responsiveness, a resilience to climate, 40% of the variation, which I think it excites me, I can tell. I mean, the way I wear my emotions on my sleeve, I'm sure you can tell I'm excited. But this is pretty good stuff, I think. The question I have not yet figured out how to approach is do we expand it to all the data that are there, or is there some limit to how big a change needs to be included? And I think it's not as straightforward. But normally you just say, let's use all the data. But if bass were in all 18 watersheds to start with, even if they benefited from increased temperatures, they can't change in watersheds. So they're somehow going to dull out this response because there's really nowhere for them to go. Conversely, if a cold water species is only in one watershed originally, and it can only contract by one watershed, that's going to dull it out too. So there's some level at which there's going to be noise in there that's not going to reflect the response to temperature just because there's not that much change as possible. But if you expand every fish species that change at least one watershed, we still explain 20% of variation, which is quite fine. If you use every species, whether it changes or not, it still explains almost 20%, and in all cases it's highly significant. So I do think there's something going on there, and maybe over beers later tonight, if I'm wrong, someone will come point it out to me, but I think this, over the span of 8 years, what we're seeing, even with we're not talking about, Matt mentioned that we don't need 150 years of climate change. We've got something that's been going on for only 70 or 80 years, and we're already starting to see a response. Now, alternative explanations for what's going on, it's got nothing to do with climate, but it's got to do with our activities. Right? They'll emphasize stocking, but New York State, stocking has been going on since the 1800s. Bass, I think Jeff Lucas found a paper not too long ago, that bass have been introduced in pretty much every county in the state by 1890-something. So that cat is probably already out of the bag. It's not like we had stocking programs that were initiated after 1930. There are still stocking programs going on, but some of the widespread species introductions likely happened as a result of early on stocking that Bob Daniels talks about, 13 species, 233 million individuals stocked back in the 1800s. So most of these introductions that we can attribute to intentional programs may have already taken place. We do have bait bucket transfers, which Brian talked about, but my question would be, what in the world would smart anglers preferentially move green sunfish around over, say, bluegill or pumpkin seed? Why yellow bullhead and not brown bullhead, which are more ubiquitous? That they're likely moving these fish, but these aren't species that anglers would be saying, damn, I sure wish I had some green sunfish in my backyard. These are, it's not like it's walleye and trout. So I'm not sure I could give them credit for doing it. So my sense is that we have movement. We also have this really nice canal system. We got fish that are capable of moving across the state and invading different watersheds of their own volition. It might take them a while, but they can do it. We no doubt have fish being moved around. I know gray sunfish and bullheads from my farm pond days in Oklahoma are notorious invaders, and no matter how high a pond is perched or how many tons of rotenone I put into it, you go back the next year, there'd be green sunfish and yellow bullhead. The local explanation, of course, was that it rains green sunfish and yellow bullhead, or they attach to duck feed, so that could be going on. But still, things have to sort out at some point. And I think what we're seeing is you take all the movement and different variables going on, species that are planting and succeeding and thriving are those who are best in hot water temperatures, and other ones who maybe get moved around too, like the trout, or not, which again makes me think climate's playing a pretty important role here. Now, in the interest of full disclosure, I submitted this paper as a contributed paper, and Dan called me and asked if I'd be willing to give it in the plenary session, as in lieu of being the last talk in the last session of tomorrow. And that seemed like a no-brainer. So two caveats, I have to be willing to talk longer, which is clearly not a problem for me. But I had to tie it into resilience, and that was a little bit more of a challenge. I had to look that up too. And I saw some pictures. I like doing image search more than the regular search because you don't have to read. But yesterday, it all came clear. This is a headline from just 24 hours ago. Donald Trump is resilience. and it all kind of fell into place for me there. That's what we're talking about. Now, the easy answer in Matt's perspective is one I agree with, is evolution. The resiliency to this change is built into the system. We clearly have species who can do just whatever the hell they want to with warmer water temperatures, and some that won't. And we knew that in 1859, that as the system changed, conditions would select for different species. But the inconvenience is that the way those things sort out may not be what the managers want. And there's different scales of approach. If we want to turn this back, or at least stop it so that we can retain the cool water and cold water species we have, obviously planetary levels of mitigation are that's beautiful, isn't it? I mean, there's another quote by a guy who's worried about some island policies. If an island go to one side because of sea level change, the island will tip over. I couldn't fit that one in to this, but I thought that. But anyway, so mitigation, that's something that we don't have complete control over, but clearly that's the biggest answer, is if we can slow down or end the warming. On a local scale, we can try to encourage people to quit stocking fish willy-nilly all over the state. We had an intern who said he and his father brought back every different species they caught, put it in a quarry pond in their backyard. That's still going on. That's not going to help. If it's not going to be the reason things change, it will at least give species a foothold in a new habitat where they can take off on. So clearly this is not something we want to see keep going on. And then the more obvious one, if we have cool water habitats in these stream fisheries, and protect the habitat or enhance or restore the habitat that gives them the refugia that they need. And then perhaps more pragmatic is just adapt. For those of you who remember the Trout Unlimited, this is BASS. Bass's preferred temperature is like 30 degrees or so they're a long way from being in trouble. And if things continue on, that's going to be what our fishery is. And then, in the interest of being complete, there is in fact one other alternative, which is just to embrace the fact that we're all wrong about this and that it's not real, or that it will turn around if we change a few of the controlling circumstances are leading to it. So I'll leave that there for your consideration as well. And if there are any questions or time for questions.
We have time for one question, if anyone has a question for Randy. Yes.
Did you think about variability, fish's ability to respond to variability in temperature, and obviously the temperature they have?
No. I mean, I'm not sure how I would. I mean, we can talk about that more if I'm not understanding what you're saying, but it's just, we're looking at what's there, and I'm not sure we can actually pick up those subtle things like who's bouncing up and down on a shorter time scale or that kind of thing.
everything?
Yeah.
Okay, all right. Well, thank you, Randy. Thank you.
So lunch is set up at the other end of the building. We